cone or a cylinder, a triangle, etc. Not that it's hard, but that's one of those sections. We got to look at all the different scenarios that they have for that. But before we do, I just wanted to wrap up section 6.2. This was the last thing we were doing, and this was volume by the washer method, right? But I just wanted to write this on the board. Isn't this what we determined in the end? That when we went around like some axis of revolution, we went around like a line x equals 2. Couldn't we just put the 2's there? And what if the line was like x equal to negative 2? Yeah, subtract negative 2. And then if it was going around the y-axis, we did this. We just made sure we wrote the functions in terms of y, right? So this right here, I just wanted to point out, I didn't want to put this in their notes. I didn't write this on the board at the end. We kind of figured that out as we were working the problem, but it's just something you might want to keep. Just write down. So this is about which axis? That's about the x-axis. This right here would be about the y-axis. And again, I mean, it'd be a great idea. Let's just start class. Let's take two equations. We can use different ones from last class. I used x and x cubed. All right, let's do just some common functions we're familiar with. How about the square root of x? And we use x squared. And let's find the volume of revolving the region bounded by these two functions about the line x equals 3. Won't tell, but we'll set it up. We'll do the setup. Let me set that up. Well, we always draw a picture first, right? Square root of x goes like that. Square root of x function curved like that. Y equals x squared, parabola, right? Eventually they do integrate. They do intersect. So there's that region we're talking about. We're talking about that region there. Find the volume of the solid that's generated by revolving this region about the line. Oh, and I wrote x equals 3. That would be, let's see. Somewhere over here, right? X equals 3. X-axis, y-axis. Okay. So if this is getting revolved like this, you all agree it's going to be dy, right? Because it's just like it's getting revolved around the y-axis. So that's when we're doing this dy. It gets revolved down to something like line equals y, right? Y equal to 3, or y equal to 2, or y equal to 5, or y equal to negative 5. Then it's getting revolved like this. That would be dx, just like the x-axis. So we're definitely going to apply this right here, true? All right. Well, to start out with, we need the limits of integration. We're going to find out where these two curves intersect each other. So let's find where they intersect. Now, some of you might know just staring at it. What does square root of x equal x squared? 0 and 1. That's where they intersect. Does everyone agree? Yeah. We can see at the origin that this value here, square root of 1, is equal to 1 squared. Of course, you could, square both sides. You get what? X and x to the 4th. You could solve that if you wanted to. Square that, you get x. Square that, you get x to the 4th, and you can factor this. But I think a lot of you realize you didn't even have to do that, did you? You still get the values what? 0 and 1. This is where these two graphs meet, right? So I'm going to start setting this problem up. They meet at x equal to 0 and x equals 1, but the a and b value, because I'm going around x equals 3, this is all going to be dy. So don't we need the y values? What's this y value? Right? 0 to 1? I'm gonna go 0 to 1. I'm gonna put my pi. Whoops. Squared. Squared. Let's do a function right here. Minus, what's this number? 3. Over here, minus a 3. The only thing left I have to do is rewrite these two equations. This was y equal to x squared, and this was y equal to the square root of x. I gotta write those such that I solve for x, right? That's the only thing we have to do. We're gonna put the outer here, right? And we'll put the inner here. So when we do that, we'll just look which one is further away from the axis of revolution and which one's closer.
X equals y squared.
Oh, good. Let's start with that one. Can you solve for x there? If y equals square root of x, what's x equal to?
Y squared.
X equals y squared. All right, got one. And that's further away from this, right? So x equals y squared, further away from the axis of revolution? All right. You're further away. You're the outer. Oh. Who's the inner? And when I need you to solve for x there, what would you get? Square root of 1. And there you go. But we were just going to set it up. Was everyone okay with that?
There's a question about, so your balance is 1 to 0, is that your x value or your y value? Because they're, I mean, in this.
Outstanding question. They have to be, in terms of this, they have to be y values because it's dy. But yeah, it was fortunate that this still came out to be what, 0, 1. A really good question. Because we're going around this, why we had to make sure everything was in terms of, dy, and we had to find out what their value were.
But if it was an x function,
We would have used two x values. So I know I wrote a and b here, and when he has a really good question. I have a, b. He's saying these two numbers here are going to be y equal to some number, y equal to some number. These are going to be two x values. These will be x values, these will be y values. And it's where the two functions or two equations originally met, which I'll put there. Cool, everyone okay with that? All right, hey, in your notes, we're going to start now section 6.3. 6.3. This is another way to find volume.